All right, so you want to write code like a craftsman, huh? We're going to dive into that today.
Yeah, build software that is as elegant as it is effective.
That's right. Think about clean code smart testing, really mastering the tricks of the trade.
Yeah, and it's not even just about making things work. It's about the why behind the code, you know?
I like that.
Like, what are the principles that are going to make this work robust, scalable? The kind of code base that's not going to just fall apart when you come back to it later.
Yeah, like you don't want to be rebuilding the house every 3 months, right? You want something that's going to last.
Exactly.
So where do we even begin? How do we start thinking like a coding craftsman?
Well, it all starts with a shift in mindset.
Okay.
It's about taking pride in every line of code that you write.
Yeah.
Understanding the why behind the decisions that you're making when you're writing code and how that can translate into a code base that can stand the test of time.
So it's less about hacking things together and more about being very, like, thoughtful and deliberate with your coding.
Precisely. And one of the most fundamental elements of this is this idea of clean code.
Clean code.
Yeah.
What does that even mean? It sounds very like,
Pure.
yeah, pure. I was going to say hygienic, but yeah.
Yeah.
So what does that actually look like in a practical sense?
Well, clean code is all about readability and maintainability.
Okay.
Imagine if you were reading a book
Right.
and the author was using inconsistent grammar, weird formatting, and like the names for the characters were just strange and confusing.
Yeah, it'd be impossible to follow.
It would be even a nightmare, right?
Yeah, you would never finish that book.
Well, code is very much the same way when it's riddled with confusing variable names, massive functions that are trying to do way too much.
Right.
A lack of clear structure, it becomes a nightmare to maintain and debug.
So clean code is almost like writing a novel that's both engaging and easy to follow.
Yeah.
But instead of like captivating readers, you're trying to appeal to other developers and your future self.
Exactly.
Right. Which is sometimes just as hard, let's be honest.
Oh, absolutely, especially yourself 6 months later.
Oh, yeah.
Yeah, you're your own worst critic. So how do we make our code cleaner? Like, where do we start with that?
Well, I mean, just think about something as simple as naming conventions.
Okay.
Right. Would you rather try to decipher what a variable named X is
Right.
or a variable named days until deadline?
Days until deadline, yeah.
Right, exactly.
Because then it's very clear what that is.
You know exactly what that variable represents. It's
Yeah.
very clear.
Yeah.
And that's just one small example.
Okay.
But meaningful names are like signposts in your code.
Okay.
They're guiding you and anyone else who has to look at your code through the logic and the structure of it.
So it's kind of like we were saying with that book analogy.
Yeah.
It's like having a map versus trying to navigate with no sense of direction.
Exactly.
Okay, so clear, concise code. That makes sense.
And it goes beyond just naming things.
Okay.
It's also about breaking down those massive, intimidating functions
Yeah.
into smaller, more manageable chunks. So instead of having one giant function that's trying to do like 15 different things,
Right.
you break it down into a bunch of little functions that each one has a very specific purpose.
Exactly. You got it.
Okay?
Think about it this way.
Yeah.
Would you rather tackle a giant, messy project all at once,
No way!
or would you rather break it down into smaller, more digestible tasks?
Always smaller tasks.
Exactly.
Yeah.
It's way less overwhelming, and it's much easier to manage, and it's the same way with your code. Just like organizing your tools in a toolbox.
Okay.
Breaking down your code into these smaller, more focused units makes it easier to find what you need, understand how it works, and modify it without causing a cascade of unintended consequences.
So this is starting to sound a lot less like coding and a lot more like craftsmanship.
Exactly.
Like you're really building something with care and you're paying attention to all the details.
That's the idea.
Okay, I like that.
And another powerful practice that goes right along with this idea of clean code is test-driven development, or TDD.
TDD, that's the one where you write the test before you write the code, right?
Yes.
It always seems a little backwards to me, but...
It seems a little counterintuitive at first, but stick with me here.
Okay.
Imagine you're building a bridge.
Okay.
You wouldn't want to just start laying down the foundation without having a set of blueprints and rigorous tests in place first.
No, of course not.
Yeah.
That's how bridges collapse.
Exactly. You don't want to risk building the whole thing only to discover a fatal flaw in the design.
Right.
TDD follows that same principle.
Okay.
By writing tests up front, you're essentially defining the expected behavior of your code before you even start writing it.
So you're establishing the rules of the game before you even start playing.
Exactly.
Okay.
So that way you know that your code is going to behave as intended
Yeah.
right from the start.
So it can kind of help you catch errors a lot earlier on in the process.
Hugely, it
Mm.
can.
Okay.
Not only can it help you catch errors earlier on, but it can actually force you to think through the problem more thoroughly
Oh,
and design more robust and reliable code right from the get-go.
that makes sense.
Yeah,
It seems like TDD would be really valuable for very complex projects where there's a lot of moving pieces.
absolutely.
Yeah.
And there's actually a really great example of this in one of the articles you shared.
Okay.
The one with the simple add function
Yeah.
where they walk through
Right.
writing the test for
The
that.
one that just adds two numbers together.
Exactly.
Yeah.
And even something as simple as that, when you start to think about it in terms of TDD, it can be really valuable
Hmm.
and can actually lead to much more robust and reliable code.
Okay, so we've got clean code, we've got PDD. What other secrets do coding craftsmen have up their sleeves?
Well, even the most skilled craftsmen,
Yeah.
they rely on feedback and collaboration
Sure.
to improve their work. And in the world of coding, that's where code reviews come in.
Code reviews. Okay, I'm not gonna lie. The thought of having my code like scrutinized by other people makes me a little nervous. Is that weird?
No, it's totally understandable to feel that way.
Okay.
But, you think about code reviews less as scrutiny
Hmm.
and more as like this collaborative quest for excellence.
Okay.
Imagine a team of carpenters
Bro.
crafting like a really beautiful piece of furniture together.
Right.
They wouldn't just build their individual parts in isolation and then like hope for the best when they assemble it in the end, right?
Boy, they'd all be talking to each other throughout the process,
Exactly.
making sure everything fits.
They'd consult with each other. They'd offer suggestions.
Yeah.
They'd make sure everything fits together seamlessly.
Okay, I like that analogy.
Yeah,
So it's less about pointing fingers and being like, your code's wrong, and more about just making sure that, like, what we're putting out there is the best that it can be.
exactly. It's about the collective code base, right?
Right.
It's about making sure that's solid. It's
Yeah.
consistent. It really reflects the best work of the team.
Yeah, it's a team effort.
Exactly.
Okay, cool. And so you mentioned solid principles earlier. What are those all about?
Ah, yes, the solid principles.
Yeah.
These are like the architectural blueprints for building really robust and maintainable software.
Okay.
It's a set of 5 design principles
Okay.
that, when applied correctly, can significantly enhance the quality and longevity of your code.
Okay, 5 principles. What are they?
Okay, so SOLID is an acronym.
Yeah.
That stands for Single Responsibility Principle, Open-Closed Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle.
Wow. Okay, I'm already overwhelmed.
Yeah, it's a mouthful.
Yeah, it's all those words.
Yeah.
Seems like a lot to remember.
It does, but each of these principles addresses a very specific aspect of software design.
Okay.
And once you grasp the core concept behind each of them, they really do become incredibly valuable tools in your coding arsenal.
Okay, so it's kind of like learning a new language almost.
In a way, yeah.
Where it's like once you know the basics, then you can start to like really speak it fluently and use it effectively.
Exactly.
Okay, so let's break them down a little bit.
Yeah.
What's the single responsibility principle?
Okay, so the Single Responsibility Principle, or SRP,
Okay.
it states that every module or class in your code should have one and only one specific responsibility.
Okay.
It's like a chef in the kitchen, right?
Yeah.
You wouldn't expect the head chef to be responsible for prepping all the ingredients, cooking the main course, and washing the dishes all at the same time, would you?
No, that sounds like a recipe for disaster.
Exactly. If they'd burn the soup, they'd drop the plates,
Yeah.
it would be chaos.
Yeah.
So just like a well-run kitchen assigns specific tasks to different chefs, the SRP advocates for breaking down your code into smaller, more manageable units,
Okay.
each responsible for a single well-defined task.
So instead of having like one giant class that's trying to handle everything,
Right.
you would break it down into smaller, more specialized classes, and each of those would just do one thing.
Exactly.
Okay.
And that not only makes your code easier to understand and maintain, but it also makes it more robust
Oh, okay.
and less prone to those like ripple effects where a change in one part of the code unexpectedly breaks something else.
That makes sense because then you know exactly where the problem is.
Exactly.
If something's broken, it's like, oh, it must be this class because it only does this one thing.
Exactly.
Okay, cool.
Yeah.
So that's the single responsibility principle. What about the open-closed principle?
Okay, the open-close principle, or OCP, this one states that software entities like classes, modules, functions
Okay.
should be open for extension but closed for modification.
Okay, that sounds a little cryptic. Can you give me an example of what that means in practice?
Sure. So imagine you have a module that handles payments for an online store.
Right.
You've got code for processing credit card payments and everything's working smoothly.
Okay.
But now you want to add the option to pay with PayPal.
Right, which happens all the time.
Right, exactly.
Yeah.
The open-close principle suggests that you should be able to add this new payment method without actually altering the existing code for credit card payments.
So you'd basically create like a separate module or function to handle the PayPal
Yeah,
payments. And that would just like plug into the existing payment processing flow without having to like mess with any of the code that's already working.
precisely.
Okay.
You got it. And this way you minimize the risk of introducing new bugs while still adding new features and functionality.
That's awesome.
Yeah, it's incredibly powerful.
So it's kind of like building a house where you can like swap out different modules or add new ones without having to like rebuild the whole foundation.
Exactly. It's like having interchangeable parts for your software.
That's a really good analogy.
Yeah.
Okay, so we've got single responsibility, we've got open closed. What is the Liskov substitution principle?
All right. The Liskov substitution principle, or LSP, this one focuses on inheritance,
Okay.
which is a fundamental concept in object-oriented programming.
Inheritance, that's where you create new objects based on existing ones, so they inherit all the properties and
Yeah,
methods.
exactly. You got it.
Okay.
The LSP states that any object of a parent class should be replaceable with an object of its child class without altering the correctness of the program.
Okay, so it's all about making sure that your subclasses behave in a way that's consistent with like the expectations set by their parent class?
Exactly. Like, if you have a function that works with a certain class, it should also work seamlessly with any subclasses that are derived from that class.
So it's all about consistency.
Exactly.
Aye.
It's like having a standard electrical outlet.
Okay.
You expect any appliance with the correct plug to work when you plug it into that outlet, right?
Right.
Regardless of whether it's a lamp or a phone charger or a vacuum cleaner.
They all have the same interface.
Exactly.
They should all work.
Precisely.
Okay.
Even though they do different things,
Right.
they all adhere to the same basic interface.
Okay, cool. So that one kind of makes sense.
Yeah.
What about interface segregation principle?
Okay. The interface segregation principle, or ISP, encourages developers to design interfaces that are specific to the needs of their clients.
Clients, so like users of the software.
Not in this case. No. When we talk about clients in this context, we're talking about any code that uses a particular interface.
Okay.
So the ISP suggests that it's better to have several specific interfaces rather than one general-purpose interface that tries to cater to everyone's needs.
Okay, so instead of having like one giant interface with a ton of different methods,
Right.
you would break it down into smaller, more focused interfaces that are just tailored to like the specific needs of the code that's using them.
Exactly.
Okay.
It's like having a specialized toolkit for different jobs.
Okay.
If you're a carpenter, you wouldn't want to carry around a giant toolbox that contains every single tool imaginable, right?
You're right. You just want the tools that you need.
Exactly. You would select the specific tools that you need for the task at hand.
Okay, that makes sense.
Yeah. And the ISP is all about designing interfaces that are lean, mean, and tailored to the specific needs of their clients.
Okay, cool. So we're down to the last one, the dependency inversion principle.
Yes. The dependency inversion principle, or DIP.
This is the hard one, right?
It's often considered the most challenging of the solid principles.
Get me with it.
Okay, so the DIP essentially states that high-level modules should not depend on low-level modules.
Okay.
Both should depend on abstractions.
Okay. I'm already lost.
Okay, think of it this way. Imagine you're building a car.
Yep.
The engine is a low-level module.
Okay.
The steering wheel is a high-level module.
Okay.
The dependency inversion principle suggests that you shouldn't design the steering wheel to depend directly on the specific details of the engine.
So you're saying don't build a steering wheel that only works with a V8 engine or something?
Exactly.
Okay.
You wouldn't want to do that.
Right.
Instead, you design an abstract interface for controlling the car's movement.
Okay.
And both the steering wheel and the engine interact with this interface.
So that way you could swap out the engine for like an electric motor and the steering wheel would still work.
Exactly, you got it.
Okay.
That's the power of the dependency inversion principle.
Very cool.
It promotes loose coupling between modules, making your code more flexible, adaptable, and easier to maintain in the long run.
Wow. Okay, so these solid principles.
Yeah.
It's quite a journey to get through all of them.
It is a journey.
But it seems like they're all about making your code like not just functional,
Right.
but also like well structured,
Yeah.
adaptable, easy to maintain,
Exactly.
all those good things.
They're like the guiding principles of a master craftsman, you know,
Oh, right.
making sure that every line of code contributes to the creation of a software masterpiece.
Okay, I like that a lot.
Yeah.
Speaking of masterpieces,
Yeah.
you mentioned design patterns earlier.
Oh, yes.
What are those all about?
Design patterns are like proven blueprints for
Sure.
solving common software design problems.
Okay.
They're time-tested solutions that experienced developers have identified and documented over the years.
So it's like we're not reinventing the wheel every time we run into a problem.
right.
We can just go to this library of like tried and true solutions that other people have already figured out.
That's a great way to think about it. It's like,
You know, if you were designing a skyscraper,
right.
you wouldn't do that without consulting established architectural patterns.
Right. There's a reason why those buildings are still standing.
Exactly. They embody best practices. They ensure structural integrity.
Right.
Design patterns offer those same benefits in software.
Okay.
It gives us this common vocabulary
Like,
and a
right.
set of best practices for solving these recurring problems in design.
So instead of every developer coming up with their own crazy way to do something,
Right.
we can all kind of agree on these patterns, and it'll make it easier to maintain the code, understand the code,
Exactly.
make sure it's robust.
It's all about consistency
Yeah.
and having these shared solutions that we can all rely on.
Okay. So what are some examples of some of those patterns?
Yeah, so a really well-known one is the singleton pattern.
Singleton, that sounds familiar.
Yeah.
I feel like I've heard that one before. Doesn't that have something to do with only having one instance of a class throughout the entire application?
You nailed it.
Oh,
Okay.
yes. The singleton pattern makes sure that a class has only one instance, and it provides a global point of access to that instance.
Okay, so like if you're building a database connection, for example,
Perfect example.
you don't want to create a new connection every single time you need to interact with the database.
Right. You don't want to be opening and closing connections constantly.
Right.
That's really inefficient.
So the singleton would just make sure that there's just one connection.
One and only one.
Okay.
You have a single shared connection,
Yeah.
and you can access that from anywhere in your application.
Very cool.
Prevents a lot of headaches and potential conflicts.
That makes a lot of sense. What other patterns do you use a lot?
Let's see, another really common one is the factory method pattern.
Okay.
This pattern provides an interface for creating objects,
Okay.
but it lets subclasses decide which class to instantiate.
So instead of the code that needs the new object creating the object directly, it says, okay, go to this factory and it'll give you what you need. Exactly. It delegates that creation process to a separate factory method.
Okay.
And this makes your code more flexible because now you can easily change the type of object that's being created without having to modify the code that actually uses that object.
Okay, that's cool.
Yeah.
It's kind of like, I don't know if this is a good analogy, but it's like having a universal remote control.
Okay.
You can use the same remote to control different devices, even if you don't know all the details of how those devices work.
I like that. Yeah, I think that works.
Okay.
And then there's another one called the observer pattern.
Observer pattern. Okay.
This one is all about establishing a one-to-many dependency between objects.
One-to-many, so like if one object changes its state, all of its dependents are notified and updated.
You got it.
Okay.
Exactly. So think of it like a subscription service.
Okay.
When you subscribe to a blog or a newsletter,
Right.
you're essentially becoming an observer.
Okay.
So when the publisher releases new content,
Right.
that's a change in state.
Yeah. You as the observer are notified and you get the update.
Oh, that's a really good example.
Yeah.
So it's like if you're building a system where like one part of the system needs to like react to changes in another part,
Exactly.
that makes a lot of sense.
For active systems, this is a great pattern for that.
That's really cool. Are there like tons of these patterns?
Tons.
Okay.
Yeah, we've just scratched the surface here. We've got strategy decorator, adapter. The list goes on and on.
Wow. It seems like there's a pattern for like almost everything.
Almost everything. Yeah. And over time, you start to recognize these patterns.
Right.
And you're like, oh, I know exactly what to use here.
It's like having this whole library of tools that you can pull from.
Exactly. And that's what's so powerful about design patterns.
Yeah. Very cool. Well, we've covered a lot of ground in this deep dive.
We have.
Clean code, TDD, solid principles, design patterns.
That's a lot of it.
It's a lot, but it seems like all of it is really about taking your coding to that next level, to like really being a craftsman with how you write code.
It's about approaching your craft with care, with precision, and with this deep understanding of the principles that are going to lead to robust, maintainable, and frankly, elegant software.
Elegant software. I like that. So it's about more than just like making it work.
Way more.
It's about making it like beautiful underneath the hood.
Exactly.
Even if nobody else ever sees it.
You and your future self.
That's right. And maybe the other developers on your team, if you're lucky or unlucky, I guess.
Exactly right. But at the end of the day, you should be proud of the code that you write.
That's right. Take pride in your work.
Exactly.
Well, this has been awesome. Any final thoughts for our listeners as they kind of embark on their own coding journeys?
Yeah, I mean, the biggest thing I would say is embrace these principles of craftsmanship.
Okay.
Never stop learning.
Right.
And most importantly, never lose that spark of passion for this craft.
Yeah, coding can be incredibly rewarding, especially when you start to see those like really elegant solutions coming together.
Absolutely.
All right, so we're going to leave our listeners with this final thought. What is one small thing you can do today to infuse your own code with a little bit more craftsmanship?
Maybe it's renaming that variable that's been bugging you.
Yes.
Or breaking down that massive function.
Or finally writing some documentation.
There you go.
Yeah.
Every little bit helps.
The journey of 1,000 miles begins with a single step.
That's right. Enjoy the journey.
All right, everybody. Happy coding.
Happy coding.